No?
Yeah.
Yeah? Okay, good. Yeah, so my name's Simon Tennant, and I work on Buddycloud. And it all started a while ago, back in the Symbian days, actually. In fact, James Bodie will know this well. He was our #1 super fan. This is all Symbian S60, and it started out as a small little. I think everybody, if you're in mobile development, you always start off with a mobile social network. It's sort of I've got a GPS, I want to know where my friends are, and you start building this. And we started doing this, and it was sort of, I guess, 6 or 7 years ago, and it was sort of like a Foursquare. You could find out where your friends were. But it wasn't really much fun, because you would have a location, and you kind of wanted to share this location, and then you wanted to kind of communicate about the location. And it was only really when we added this communication angle that things came alive. And it's sort of like the internet's driven by communication. You've got little post boxes on Facebook or text entry boxes on Twitter, and everything we do is driven by the text we put in these boxes. So yeah, we sort of started out with this and somehow ended up with something that looks like this. And so this is really the story about how we've gone through and turned a product into a protocol. Because right now, our sort of architecture, and this is the Buddycloud app. Basically, if I'm summarizing Buddycloud, it's a set of tools and services that developers use to build communication into their apps. It's all open source, all built on open protocols, and we're currently building it really as a set of microservices. So you can sort of pick and mix like the different pieces of software that you want to add in. So if you want to just do messaging, you would just use something like a chat server. But if you need to add mobile, you add extra services in. So this is sort of the high-level summary. But we started out building this product, and we started out with probably a little bit more ideology rather than pragmatism. And we sort of slowly moved down the pragmatic scale. And right now, there have been other products that have tried to sort of build an open social network, open communication system. Sort of like, I guess you guys probably remember Diaspora. There was this, like, we should kill Facebook with something that looks just like Facebook. And you're never going to do that. And you're never going to build a winning product based on competing with directly competing with a very well-funded closed product. So we kind of thought about, like, how can we get this out there? And really the problem is that developers just have a hard time. They build this app, their boss comes to them and says, look, we need to add messaging to this app. And the poor developer's sort of stuck there. There's all these problems that they have to deal with. Messaging is just complicated. If you want to like have messaging going to your mobile app, you've got to think about how do you resynchronize these messages? How do these messages get there securely? How do you do push notifications? And then you've got to run it all in production. And so you start having this very, very complicated world. And this is like, you think about the average app with messaging, it's maybe something like the Airbnb app, for example. You've got hosts talking to their guests. That's not the core part of the app. So messaging is this big complicated beast that the poor developer is supposed to stick into their app, but they're actually just trying to ship their app. So they get super distracted by all the requirements of messaging. So we're looking at this and then thinking about, we want to like compete against Facebook and some of these proprietary services. Well, like the way to do this is to really try and solve these real problems that developers have with open source and open protocols. So, it's always a good idea when you're thinking about these things to kind of go back and think about how have other successful apps solved this. So here's my question today. I'll get a beer for anybody who can name probably the oldest internet app out there. Most successful app, most users. Any offers?
Mail.
Okay, James Bodie gets a beer. Yeah, so I thought, like, who can I speak to about this? And I found out that this guy, Eric Orman. In fact, he can probably see send mail on his T-shirt, so it's cheating. Anyway, yeah, 35-year-old app. It's been around forever. It's open, it's federated, sort of ticks all of the feel-good boxes, unless you have to actually deal with it on a day-to-day basis. And unless you have to contact this guy. It took like a month and 3 or 4 different email addresses to find Eric Orman. And we started having this chat because I really wanted to understand, like, you've built this super successful app. How did you do it? And what were some of the driving forces at the time? So I was talking to Eric, and he explained, we used to have these messaging silos. There was UECP mail, there was the ARPANET, he was at Berkeley at the time, and there was BerkNet mail. And even to send messages between these systems, you had to like unplug your terminal, plug it into a different system. I was like, wow, this is sort of like the whole, get messages on Skype. I've got to log into one app, or I get messages on another service. And we're apparently like living in the future, and yet we're dealing with exactly the same bullshit that these people had to deal with 30 years ago. So he was talking about, the process of banging heads together, how flattening the namespace out, so you didn't have crazy, like UECP messaging where you had bangs between different things, and you actually had to build the routing into the user's email address. So, I mean, the simple takeaway from what he did was that the user doesn't care about the back-end system. The user just cares that they can contact their friends with a sort of simple naming structure. So it's user at domain. And yeah, he went through, he published SendMail. There were 3 or 4 different competing versions of SendMail. There was the King James SendMail. There were a couple of proprietary SendMails. But overall, there was a nice gentleman's agreement, like when my server wants to talk to your server, this is how we're going to talk and get stuff to communicate. And the other takeaway was that they got a successful system, and then they turned it into a protocol. It never happened the other way around. And this was something that bothers me about a lot of standards committees now. Like I work, as Daniel said, on the XMPP standards committee. And probably 50% of the time you see these standards coming through, which are sort of these like wishful standards. It's like, I wish everybody would do end-to-end encryption. And somebody writes up a spec, and it sort of gets pushed through the system. And maybe 25% of those actually come through, and then you've got the spec, and it's a spec for end-to-end encryption, and it doesn't really work because it was somebody wishing that something existed without testing it on real users first. So email was successful because it was tested on real users first. So, and it was also successful because it was open, it's federated. It's reasonably real time. It's certainly quicker than some of the store and forward systems that were existing at the time, where you'd have to dial into different BBSs, and once a day, different BBSs would contact each other. And it's relatively affordable. So then we're thinking, like, well, what does this spectrum look like? I mean, ideally, we all want to we're here because we want to build successful products, and we want to have lots of people using them. So my sort of thinking about this was, we've got the crazy, sometimes widespread use can actually be closed. But you also get these API approaches. And I've never really bought into this, like, oh, we're open because we have an API model. It's especially when you read the developer mailing lists, and you have like chief Twitter engineers telling you, like, you should develop in this quadrant and not build these type of apps because they compete against our service. So ideally, you want to be heading towards something that involves the sort of intellectual rigor of your peers challenging you, and get good standards coming out of it. And eventually, when good standards come out, you get things like that. Don't ask me how the PSTN got there, but certainly email made it. I'm sure there's better telco people. So there's a standard, and then there's like actually people getting to the widespread use part. And so we've standardized, and we're in the process of standardizing more parts of Buddyclouds. But just throwing a standard over a wall is not going to change the world either. So we're really trying to build this ecosystem around the open standards and the open source that we're making. And to do that, we're trying to make it relevant for these developers. The developer who has the boss coming to them and saying, please add messaging to this app. And some of this is, we've built a lot of the stuff on XMPP, and I'll go into that in a minute. But it's got to do the sort of basic things that you expect. It's got to have user management. It's got to be easy to integrate into your app. This is something that actually surprised me, this hosting thing. I sort of come from the world where you apt-get install and you run it on your home server or your shared server in the data center. But it's actually amazing. If you want to work with developers, turns out developers just want to build stuff, which maybe I'm just slow in getting this. But when we started saying, oh, we can host it for you as well, suddenly people were really interested, and they're like, this is pretty cool. And they started building stuff quicker. So if there's one takeaway you take from today is if you want to roll out a service, give people free hosting or just something that jump-starts them without a lot of friction of setting up servers. And finally, we have a little commercial side where we work with companies. We do licensing and support and help them roll out their apps as well. And these are some of the products or some of the customers that we're working with. Interestingly, I believe deeply in the federated side, but I sort of put that in the ideological box rather than the practical box. But it turns out that some organizations really care about this federated side, and that's for the reason that the user base is often fragmented. So something like the UK government has a bunch of users in maybe the Home Office sitting in an Active Directory server, and they need to communicate with a bunch of users in the Department of Game, Fisheries, and Wildlife. And the federated nature means that these users can then talk to each other. We did some work with BMW, and BMW North America has very different privacy policies to BMW Germany and Switzerland. And that means that they can build services with one set of privacy policies in one area, with another set of privacy policies in another area, but they still interconnect and share information. So the federated natures actually turns out to be quite interesting. And another project we were doing in South Africa was this different regional governments interconnecting and sharing information. So federation is sort of coming back into vogue. At least that's sort of what we're seeing out of real business use cases rather than a grow your own sackcloth ideological world. So yeah, in terms of, I found this diagram interesting because it's really thinking about, if you want to add messaging into your apps, a few years ago you had to really build everything yourself. Now there's more services out there. There's services like Layer, like Matrix, where they give you a bunch of components to do it for yourself. And it's actually quite similar to the Android ecosystem. You've got this core set of services, but everybody's got a different idea of how messaging should work, and you kind of want to add your flavor. Like CyanogenMod adds their flavor to the Android core. Different applications and different companies have a different idea of what the application logic should be like inside of messaging. So, as I mentioned earlier, this is the technical part of the talk. Everything we do is built on XMPP. There are some people who like it, some people who hate it, but at the end of the day, we're lazy. We wanted a sort of messaging core that solves a lot of problems straight off the bat, so we can sort of add value at a slightly higher layer than worrying about how do servers find and connect and share information with each other. So for those who don't know, XMPP is sort of like this ingredient. It's often hidden away in other services, or successful services like WhatsApp start off with XMPP and then pivot off. Because you use XMPP in your messaging stack, it doesn't mean that it has to be open. It doesn't mean that you have to federate. But it does mean that you can get started really, really quickly because there's a bunch of smart people who've done some good thinking before you before you picked it up and started using it. Interestingly, like Google uses it not just for Gtalk, but they also use it a lot for their Google Cloud Messenger. So your phone is always running an XMPP stack, not necessarily getting XML, but getting their own binary version of the protocol. Yeah, so XMPP gives you a bunch of stuff straight off the bat. If you're starting to think about a messaging stack, it's a nice way to get going. It's, of course, real-time. I can't imagine building a service that's not real-time today. It includes identity. There's security built in. The scalability thing often comes up. People are like, oh, but it doesn't scale. And my rebuttal to that would be, if WhatsApp can spin up XMPP or Google can run a couple of billion users on Gtalk, the stuff scales. It's not a protocol problem. That's an implementation problem. And the guys from Tigas have done a lot of really good work. If you want to pick up an XMPP server that scales very quickly off the bat, check out the Tigas server. And then this discovery stuff is quite nice. There's especially on the Buddycloud stack, where we're building a lot of separate services. You want these services to be able to find and discover each other. And so XMPP uses DNS for a lot of this discovery stuff. Internet of Things is popular now, and there's the interoperability with that. And it gives you a bunch of all the sort of things you'd want straight off the bat. And finally, like, is this person online or offline? Strangely, this one is the one that's sort of becoming less and less important, especially in a more and more mobile world where, is somebody online or offline when they're driving through a tunnel? Like, how do you sort of start evaluating this? And pretty much the approach we take is like, you're just always online, and the messages should get you and find you somehow. So, quick XMPP primer. Imagine it's like your email network. You have your IMAP client, you have a server finds another server and gets to the client. XMPP is somewhat similar, but sort of in real time. So Romeo wants to talk to Juliet. Romeo's got a client. He talks to his home server. His server will discover Juliet's server and route the message through to Juliet. Pretty simple stuff. The cool part is that these don't have to be users. These can be other processes. So the machine-to-machine aspect is quite nice. You could have, we have a service called the Friend Finder. So you can connect to this other service, send it a bunch of hashes, and it'll tell you, based on those hashes, like if you know anybody, these are hashes of address book entries. So these can be users, they can also be services. So it's a nice way to build these real-time services and have them addressable anywhere on the internet in a federated way. Now, some of you probably, if you're from the web world, will probably like squeal and run away. This is XML. It's a little bit scary to some people. Some people are afraid of angle brackets. The good thing about this is that it's really extensible. You can decide we need another element into this XML tree. And when you look at XMPP, it's really just one long XML document. Your server goes online, and you're just sending these messages through. And eventually, when you finally go offline, it closes the XML document. But it's a nice way to build services because there's a huge set of libraries out there that sort of take care of everything for you. So that's XML. Web developers think in terms of REST APIs or WebSocket APIs. You need mobile and push, and there's about 4 or 5 different ways to send a file. So this doesn't get people started very quickly. So one of the things that we've done is we've tried to distill all of this down and give web developers and mobile developers a nice way to use XMPP, just to build on top of it without having to think about stuff too much. These are 2 of the demo apps that we've built. And we built these by getting rid of the XML. Like we said, you don't have to know anything about XML. You don't have to know anything about XMPP to build good messaging apps. As long as you can talk to a REST API, you should be able to just build and extend these services. And then, there's this approach of building monolithic versus microservices. And microservices, I guess it's coming out a lot of the work from the Netflix architecture. They've really gone heavily for a micro-architecture approach. And it makes so much sense. And the good thing about XMPP is that you've got all of these services that can just plug in and run on this messaging architecture. You don't have to think about restarting your entire stack. You can basically pull different services on and pull them out as necessary. And if you're running a good XMPP server, it'll also load balance between these services. So if you're thinking about a messaging stack, XMPP is quite a nice way to think about it because you get a lot of these things for free. As I mentioned earlier, each of these is then a microservice. So you have a media server. If you spin up another media server, your good old XMPP server will say, oh, there's another media server here, and it will load balance between the two media servers. So you're getting a lot of these things for free. If I look at, you've got XMPP. It's really just passing messages between endpoints. If you want to build nice apps, you're going to want to do things like request messages since you were last online, or allow certain users to send you messages, or block other users, things like that. And so you've got to add this extra layer on top of your XMPP server. And that's what we've built here. This is an open source server written in Java, plugs into your XMPP server in much the same way that your Apache or Nginx server will just proxy back to a node process. This is really just a Java process running outside of your XMPP server, but receiving messages and then sending messages back. And this is pure publish-subscribe. So you've got a user. If it's a user-to-user conversation, you've got one user and one subscriber. If it's a group conversation, you've got one user and multiple subscribers. And the publish-subscribe methodology is just a really nice way to build things because it's simple. You've got different processes or services that can then listen for events. And it's pretty much like Twitter or Facebook or any of these services. It's just like you publish one thing, multiple users get it, or a single user gets it. And then it's also nice and extensible because, in fact, this is something that we built on the very first Symbian application that I showed you. We had a way to share location. So you think about the publish-subscribe world, your location is just another publish-subscribe node. And as long as you update that, anybody who's interested in your location is then going to get little updates. But it gets more complicated. So you have a user. You have their publish-subscribe nodes. So like these are the geolocation or the posts. So that would be like a Twitter stream or a status. I'm happy, I'm sad. But then you can also decide, like, with different application logic, who can follow this user or how they can interact. And one of the things we learned is that there's a lot of bad actors out there. So I remember being on the phone many times to the ops team at Airtel India. I don't know why it was always Airtel India, but there were always these users that were spamming the network or creating problems. And we were trying to solve this with a sort of please be nice approach. But actually, when we gave users the ability to flip from one role to another role and just push some of these bad actors into a banned group, things changed a lot. And so when one's thinking about a protocol, I guess it's an API is a sort of like Band-Aid solution. If this app does bad things to the overall network, you can just revoke their application key. But if you're dealing with a protocol, it's going to be much more difficult to do that. There's no application key that you can revoke. And so the protocol design that anybody comes up with is you're going to have to think about how do you deal with these sort of edge cases. And We know that we can solve these things. If you look at something like Wikipedia, Wikipedia solves this. Like you give the people who want to do good more tools and services over the people who want to do bad. So I can mess up a Wikipedia page and take 3 minutes doing it, but if I'm a good actor, I can revert that change in 3 seconds. So there's the same sort of design approach in protocol thinking, where you can say, if we build things for good actors into the protocol, then we can make the overall network work. Email, I don't know how you solve the spam problem, but maybe that's just an earlier version of protocol thinking. So yeah, and then any publish-subscribe node always has these sort of metadata things. And so if you're building a messaging service, you probably want to say, this is my channel, or this is channel type. Actually, this is interesting, because when we're designing the Buddycloud server, one of the things we had was this idea for plugin architecture. And right now, that's actually turning out to be quite useful. There's a project where the Estonian cert and the UK cert share IETF incident reports. And by having a channel type meant we could then just have different types of messages plugging into that. Yeah. Final problem that we had to solve to make this really work well for mobile was the fact that when you take your phone out of your pocket, you've got to get messages fast. You don't want to sit around there waiting for a slow time to glass. This time to glass has to be less than a few seconds. But if you're on this big federated distributed social network, you can't have your poor mobile going off to all of these things and saying, is there a new message? So instead, we built this inbox, and we said, like, any new messages that come in should just sit in your inbox. So then you're just querying your local Buddycloud server or your local XMPP server for new messages. And this really helped solve a lot of the problems with mobile discovery. And of course, anybody who's been in the IRC world, you have these net splits where one domain will go down, they need to come back up and resynchronize. So this is something that the inbox solved as well. Your server goes down, it goes out, looks for subscribers, I'm back online, gets new posts and synchronizes them. So I realize we're running out of time, but there's a bunch of other services. The media server, never try and send binary data over a signaling protocol. I think we all know that. That's why we use HTTP where HTTP works and XMPP where XMPP works. Never the two shall meet except for passing tokens between them. So in terms of speeding up, we've built other services. There's an API service. It's written in Node. It means that you can quickly extend it, or your web developer can extend it nicely. Push notifications, friend finder, terrible name, very useful service. Taste Engine's nice because it'll let you scour the network and find people. If you follow these channels or these users, maybe you know this user. And that's all just using the Buddycloud protocol to go out and build up a taste graph of who's following who and recommend people. And there's real-time search. And our main aim is to get open protocols out there that are federated, and we're only going to do that by making it easier for developers. We can't bang people over the head with ideology. So, of course, we work through open standards. And this is something we're quite excited about. We haven't really mentioned it yet, but what we want to do is we keep getting contacted about Slack. Can you do Slack? And different people are building little Slack clones on top of Buddycloud. Realize actually we've got to just build this now, and so we want to do a Kickstarter to build essentially a Slack behind the firewall that anybody can spin up. And finally, just we've got all these different services. We've standardized the Buddycloud service. We want to standardize some of the other ways of doing media and push and stuff like that through the XMPP Standards Committee. And that's Buddycloud. Thanks for listening.
Thank you. I see James is already armed.
Yeah, armed and dangerous. I've been following, I've been a great fan of Buddycloud for many years now, and I'm getting frustrated. It's absolutely brilliant platform, but it's just not really got this massive traction that it deserves. So how are you going to push it forward? Are you going to produce modules that plug into Kamailio and then overnight everybody will be using it? That's one way of doing it, perhaps.
Okay.
Or,
we have a gateway, actually.
but that's a straight XMPP, isn't it?
Yeah, it's one built back in 2002, 2003. So I kind of started, but not really maintained. However, yes, XMPP being another open protocol, there are more from like standardization groups, the XCUSAC, so some services already combine the two. We all know the big failure of the SIP working group with simple extension for presence. So yeah, it's where XMPP tries to help in the SIP world. But yeah.
Yeah, there's a lot more to Buddycloud than just XMPP, as we just seen, had explained.
Yeah.
It does a lot more of this really clever stuff that that people really want. And are you going to do anything with Matrix?
Yeah, I guess we could do whatever. I suppose like the approach we would take for that is just building a gateway so that then the two services can gateway between each other.
So the real fight will be after Matrix presentation when they can actually fight properly.
Well, I liked your talk so far. I really believe in federations and open standard protocols. But when you talk about a gateway, can't you agree on a protocol so we don't need messy gateways?
Well, there's a really good standards group that's working on this whole federation thing. And I would love Matrix to join the standards group to talk about this.
Yes. Last questions, if someone has it. Not to put much pressure on Simon. He will be, again, around and he can help. I think, yeah, XMPP is used a lot for machine-to-machine communication. I think Pascom said that they are using as well for their platform. So thank you, Simon. Thank you for coming.